I'm not sure how that works. But you will probably get to know these students maybe a little bit if they talk, if I call on them. So just like really fast, can we do like a go around the room and do you want to go handheld?
Yeah,
you want to go handheld for a second? This is exciting. We're having a
first hint.
You know how to do this? You just flip that thing, yes. So, and then you just put the thing in. So just going around the room, everyone just like say hi and just like say your name. Unless you, if you're really don't want to, like you're ridiculously shy, you could just say, I'm in doofus. And then you don't have to say your real name. Or you could make up a cool name, like if you always wanted to be called like, you know, Evelyn, you could just say like
Wait, did you introduce yourself?
Oh, I'm Mr. Rose. I introduced myself in the intro video that I haven't recorded yet.
Okay. Should we start?
Yeah, let's start.
Oh, I'm Kendall.
I'm Robbie. Eob.
I'm Sandeep.
I'm Alice. I'm Sydney.
I'm Ethan.
I'm Scott.
Raymond.
I'm Shafani. Yao. Laura.
I'm Eric.
Chatzma.
I'm Simeon.
I'm Steven.
I'm Igna.
I'm Daniel.
I'm Hobbs.
I'm Anna.
I'm Mateo.
I'm Rohan.
All right, cool. That was really awesome. All right, good. Put the thing back on, and now what we're gonna do is we're gonna start calculus. So that was the intro.
Wait,
now we're gonna actually really do it. And before we can solve these problems, we first need to get good. We need to get good at infinity. So we need to learn like tricks and tips. Tricks and tips for dealing with infinity. And what we're going to do is we're going to talk about these things called limits. Now, fortunately, you have already had a quality pre-calculus education on this subject, so you already know lots of things about limits.
What's your
But
title?
what's up?
Which
What
I
should you title this?
title is
Introduction to Limits.
Okay.
That's what I would title this if I were you. Introduction to limits. Okay. What are limits? I'm gonna just draw some pictures. We're just gonna kind of like wing it. So we're just gonna wing it with some pictures. So here is a function, and it looks kind of like this. So whoop, and then at point A, this function jumps, and then it kind of like does this. Let's say. And this y value is L, and this y value up here is K. And now I want to say some things about this function. Like I want to say, what is what is the limit as what is the limit as x approaches a of this function? And what I mean when I say that is, so what does that mean? What does that actually mean? That means what the answer to this question is supposed to be, well, what happens as I get infinitely close to a, what y value does this function get closer and closer to?
Okay.
Wait, what?
Wait.
Say you have
What?
again?
Yeah, things are getting weird. Laura, you're looking concerned, right? There's furrowing of brows going on among the students in the room. And that's because I don't know what's going on. I'm confused. So let me just ask some more specific questions first. What is the limit as x approaches a from the left? All right. And by this symbol, I mean as I am getting infinitely close to a, but always staying to the left of a, what y value is this function getting closer and closer to?
K.
K. Everyone agree?
Yeah.
What is the limit as x approaches a plus of this function? Now, by this I mean, if I get infinitely close to a but staying a little bit more than a, what y value is this function approaching?
L.
L. And in fact, since for numbers just to the left of a, the y values are getting closer and closer to k, and just to the right of a, the y values are getting closer and closer to L. In fact, we say that this limit does not exist. It does not exist because there is no one y value which this function can be said to be getting closer and closer to. Is everyone okay with that? Okay, more. Here is a function. How about it just does this? and then and then this is just like L. Okay, so this one's a little bit boring. What is the limit as x approaches a from the left of this function? What y value is this function getting closer and closer to as I take points which are just slightly to the left of a?
L.
L. What is the limit as x approaches a from the right of this function? What y values is the function approaching now as I get infinitely close to a?
L.
Again, L. Thus, what is the limit as x approaches a of this function? L. Ta-da. Okay. Cool. Oh, there's more. What the more is, okay, watch this. New function. Yeah, maybe you don't have to like write all this down. Maybe you can just pay attention because it's all kind of like common sense-ish. So here's this, and now here's this, and now here's this. Okay, the interesting thing about limits is I am not interested when I say what is the limit as x approaches a of a function. I am not interested in the behavior of the function at a. I am only interested in the behavior of the function near a.
Oh.
So, when I write as x approaches a, I mean when I'm infinitely close to a, but what's happening at a is completely irrelevant to the discussion whatsoever. So is there a y value that this function gets closer and closer to as I get closer and closer to a? Yeah, what is it?
L.
L. Ta-da. Answer's L. And then there's like more things. I don't know. What should we? Oh, and then like I guess we could even have a situation where the function did like maybe like this or whatever. So now like that's L, that's like M, and that's K. And now I can ask all kinds of questions like, what is the limit as x approaches a from the left of this function? Everybody on 3. 1, 2, 3.
No.
Yeah. What is the limit as x approaches a from the right of this function?
K.
Okay. The actual value of this function at a is m, but that's just like irrelevant. Irrelevant. When we're talking about limits, we're talking about what the function is doing near, not what the function is doing at. Okay. More. A couple just more small things. We would also like to, suppose I give you a function like this, which looks like, I would like to be able to say things like the limit as x approaches infinity of this function is
L.
L. Yeah, I'd like to be able to say that. So somehow we have to like tweak our definition such that I can take into account things like that. And I'd also like to, suppose if you give me like volcano function, something that looks like that, I would like to be able to say that the limit as x approaches a of a function is
Infinity.
Yeah. Seem reasonable? I think it seems reasonable. All right. So this is a super informal introduction to limits. A formal introduction to limits will follow. And for now, though, I think we should just like do some. So I'm going to hand out a worksheet. And I guess the idea, if anyone's following at home, is you can go to my website and the worksheet is posted there or something. But for you guys, we're just going to do math.
Sure, stop.
No, don't stop. Just keep it going because we're going to like talk and stuff. Alright, so you don't know how to do like anything at the moment, which is kind of fun because it means you're just going to do everything wrong, but it's going to be awesome. And you're going to learn from it. So without any further instruction, just start. Just like go. Figure out these limits.
Do we do like the same thing that we've been doing?
I'm not even telling you what to do at all. I'm just telling you to just try something.
Do we just what's happening? We just divide?
I don't need to like talk to the person next to you.
Oh, like we divide by x, right?
Wait, no, this is x goes to 1.
I'm fine. Whatever.
Right, x goes to 1.
Is this gonna be like that table that like looks pin for like?
Yeah, basically that whole divide by x thing, that only makes sense if we're going to infinity. Right, which we're not here, so that's not gonna help us. Yeah, some of these aren't really hard.
I don't know what this looks like.
So equals 0.
So 0.9 is going to be very small.
Negative.
Oh, right, the bottom's going to be small.
So much like that. I think I went too slow. That's why I'm
Negative 0.9 minus 1.
Yeah. Negative.
1.9 is less than 1.9 cubed is less than 1.
But technically it's gonna be smaller.
So it's going to be positive.
No, it's
Oh,
gonna be.
yeah.
Infinity, we could just say, well,
No, like, we don't, because this is going to like really
Wait, why are we doing an x goes to negative?
Yeah, but they probably like
It's like something like that where it's just like disappears.
I don't know what we should do. It's just potentially we could just like you could just put the camera on some table and like I don't know, they look like they're working and stuff. No, don't use a calculator. Like, try to do something smart. Okay, so here's the thing. This whole divide, this whole
Minus 1 is
but
that?
it only makes sense if we're
It's gonna be less than 1.
Why?
So this is gonna be negative over what? Yeah. Negative over negative.
Because remember when like sine gets really
So it's going greater than 1.
I mean, if you start with something a little bit bigger than 1, then you get a value over 1. If you start with a value that's under 1, then you get a value that's
But you can't actually do that.
right? Something like that.
No, they're both
It'll be like,
So it goes from
because it doesn't go this way.
I'm pretty sure it's like the 1.0.
Like, when you get 0.999 cubed versus 0.999, you're gonna get close to it.
No, so okay, let's talk about this first one. Sorry, yeah, we're gonna try that. So what's going on here? Someone explain to me what's so weird? What's weird about this? Oh yeah, it's great. You guys are so wrong. It's awesome. It means your potential for learning is so high. Because you know nothing. It's like great. What's going on? Explain what's going on here.
So you're trying to find the limit as x goes to 1.
Yeah,
that function. So, well, how we did it is we just like examined like the two separate cases, like 1 minus and 1 plus.
Okay.
And so,
Well, before we yeah, keep going.
okay, should I actually say what we did?
I don't know. No, maybe not. Wait, what's going? So hold on. Like, okay. First off, this function is undefined at 1, right? Okay, that's good. Fortunately, I'm not asking about this function at 1. I'm asking about this function near 1. Okay. So when I'm like infinitely close to 1 or something like that, what does this function look like? This is basically the question on the table. Rohan, you cool? Okay. Ron, what does this numerator look like, roughly speaking, when x is very, very, very close to 1?
0.
0. That is correct. This numerator is roughly 0. Rohan, how about the denominator?
0.
It's also roughly 0. Okay, what's that? What's 0 over 0? What is
No
0 over
idea.
0?
Doesn't exist.
Yeah, Rohan says doesn't exist. Mateo says not really, and then he sort of trailed off. Yeah, you definitely can't divide by 0, right? So 0 divided by 0, not a thing. Fortunately, however, this is not actually 0 over 0. Because this denominator is not actually 0. It's just close to 0. And this numerator is not actually 0 either. It is just close to 0. So this is not actually 0 over 0. Actual 0 over 0 is undefined. This is what I call a 0 over 0 situation. Alright, so, that's a technical term. So what is the limit of a 0 over 0 situation?
Like infinity. Is it?
Yeah. It depends. It very, very crucially depends. Okay, flip to the back of your paper. We're going to do like a little learning for like a second. I will explain to you how it depends. So let's take the limit as x goes to 0 plus of x squared over x. So, is this a 0 over 0 situation? Is the numerator going to 0 and the denominator going to 0?
Yes.
Yes. And by the way, what is the limit? The limit turns out to be, upon further algebraic simplification, 0. Does everyone agree with that? Oh, I'm not going too fast, am I? Too bad if I am. Okay, what is the limit as x goes to 0 plus of x over x squared? Is this a 0 over 0 situation? It most certainly is, right? The numerator is going to 0 and the denominator is going to 0. Yet, upon advanced algebraic simplification, this turns out to be just like this, right? And what's 1 over a tiny positive? Okay, and I can just like do this forever, right? What is the limit as x goes to 0 plus of like 3x over x? Is this a 0 over 0 situation?
Yes.
Yes, but it turns out that the answer is 3. Okay, and in fact, when you have a 0 over 0 situation, you just have no idea what the answer is going to be. And since you have no idea what the answer is going to be, you're in a temporary state of ignorance. And this, what we have a name for this, we call this an indeterminate form. Indeterminate? Yeah, that makes sense. Indeterminate form. In other words, you cannot determine what the limit is, because it is in the